Questions as you can today, right? Yes.
I was gonna ask, when we take the test on this chapter, will this stuff be on there as well?
Yeah. Yes. Now the reason that I don't think it's good to do all of it and then take a test is because there's so much stuff. So I might even have a little tiny quiz next week also to do the second half, but it would be on everything. All right, let's talk about homework. This is Thursday, right? Okay, so I would say it would have been all right if you hadn't started yet. I think you'll be all right because the lesson today is the way your author starts out the chapter. Your author starts out the chapter with scientific notation. I'll be doing that today. The book takes about 3 or 4 pages to tell you about scientific notation. I promise you, I can teach it to you in about 5 minutes. And I can teach it well in 5 minutes. And that's part of the latest lesson today. The same thing is going to happen when they do temperature conversion. They're going to spend about 7 pages showing you about how to convert from one temperature scale to another. And I know I can teach it in about 15. So I understand. You can go and read the 7 pages. I would scan them, but I probably wouldn't read those. All right, is everybody ready? Now, so let's see how much you remember from 2 days ago, and I reviewed it yesterday. This chart right here called Powers of 10, right? It's very powerful. As a matter of fact, it's so powerful that everybody in the world uses a number system that's based on this. Isn't that interesting? How many languages are there? So that there must not, over 200, there must not have been, over 100 for sure. There must not have been a language that was so good that everybody said, well, we're throwing our language away. We're starting a new one. But this right here, everybody on the planet that uses numbers, they use a decimal-based system of powers of 10. So when they decided to do the metric system, right about a little before 1800, they said, how can we get the whole world to accept this system? Let's base it on something that they already know. They already know how many dollar bills it takes to make a $10 bill. We did. They know how many dimes it takes to make $1. So then we can tell you how many decigrams does it take to make a gram. It's 10. It's the same pattern. You get that? The money system. They decided to use, first time ever, a money system was based on powers of 10 was Thomas Jefferson did it here in the United States. He was the 3rd president. Okay, you okay with this? Now, what are some of the other patterns here? The patterns, for example, notice that if you're a number that is 1 or higher, this has 3 zeros, and it's also known as what? 1,000 is known as what? 10 to the 3rd. And a million must be 10 to the what? And a billion is 10 to the 9th, and a trillion is, see? Now, there's good and bad news. Here's some more good news. If 1,000 is 10 to the 3rd, what is 1,000th? I like that. But 1,000 had 3 zeros, but 1,000th only has 2 and a 1, doesn't it? Or 3 decimal places, right? Can you remember that? So that's one little catch there. So if I say, what is 10 to the 7th? How quickly can you tell me what that is? Well, that was quick. What was it?
10 million.
Yes. What if I say 10 to the 11th? Yes. Ooh. What if I say 10 to the minus 7?
No, 1 million. Negative 1 million. 1 million.
10 to the 7th is 10 million, 10 millionths. What's 10 to the minus 13th? Oh. What? Say it again. Yes, 10 trillionths. What about 10 to the minus 2? Hundredths. See, if I can get your brain to say million, 10 to the 6th, a billion, 10 to the 9th, a billion, 10 to the minus 9th, I can take you lots of places in science. All right. Anyway, that's some patterns, wasn't it? And then we had to learn our prefix, didn't we? So if you were going to make a flashcard, here's what I would do. If I were making a flashcard, I would say, on one of them, I'd say 10 to the 6th. That'd be on the front. Now, what would you put on the back? What do you know about 10 to the 6th? It's a million. You know that it's, the prefix is what? Not for million, mega millions. Mega millions. And the abbreviation is? Yeah. And if you want to write out the number, you could, but it has 6 zeros, doesn't it? So if I were going to make flashcards, I might do something like that. And, okay. Now, I don't know if you had time to read this story. Maybe you didn't. But this story I told yesterday, there are 2 other things that are not prefixes that belong to this idea. And if you're a science student, you're going to hear the word micron and angstrom. How many of you ever heard that word before yesterday? None? Okay. So I can tell you right now that if you start reading books about little things under the microscope, you'll see that they'll use, it's so many microns long. Or so. You ever heard that? Have you ever heard that on a TV show, like hairs, and they talk about how thick a hair is? And no? Okay. Anyway, if you listen for it, you'll hear it. So what is a micron again? What is a micron? That's not micro. What's a micron?
A millionth of a meter.
Say it again. Yes. Yes, a micron is a millionth of a meter. It's 10 to the minus 6 meters, isn't it? The old name for that would have been a micrometer. So a micrometer is a micron, isn't it? So micron cannot be used with something else. You can't say micron gram. Can I say microgram? Yes. Can I say micron gram? No. Micron is not a prefix. But what power of 10 is it associated with? Leroy, what power of 10 is micron associated with? And see, that's what I need. When I look at your eyes, I'm trying to look at your eyes a little bit to see where you're at a little. What do you think? Do you know? What power of 10 would micron be associated with? 10 to the what? Yes, 10 to the negative 6. Now, if you're going to measure things in a microscope, you might use microns. What about something even smaller than that? I mean, a lot smaller. What if you want to measure the size of atoms? Nanometers would almost be, they're too big. They're too big. So what's smaller than a nanometer? Yes?
Angstrom.
Okay, what is the meaning of an angstrom then?
It's not just like how they measure atoms.
What is an angstrom though? How big is it?
10 billion.
Say it again?
10 to the negative 10.
Yes, 10 to the minus 10 what?
Oh,
Somebody said it.
okay.
It's a distance unit, isn't it? So it's 10 to the minus 10 meters. It's a 10 billionth of a meter stick. Okay, that's the third time you've heard that. Get that? It's about the third time you heard that. So that's enough review there. Now let's go over here. I'll tell you what. I had somebody come in for a help session this morning. I thought it was a really good help session. But I thought, I didn't write on this one. That's good. That's good. We were doing some of these yesterday, weren't we? And what's interesting is by basing the metric system on powers of 10, if you want to convert from one to another, it's absolutely easy. It is not easy in the English system. 5.6 miles is how many yards? That is not easy. I promise you it won't have 5 and 6 in it. But if I say 5.6 kilometers equals how many centimeters, I promise you it's going to have a 5 and a 6 in it. You just move the decimal. No wonder the whole world uses it. You get it? So now, here we go. Let's play a little game here. Did we do all of these yesterday or just do that many? We did all in the first column? Did we stop right here?
Yeah.
Okay, let's do the next one. 0.7 liters equals how many milliliters? And let me call on, I don't know. How about Libby? You ready? You're ready, aren't you? I'm always ready. Okay, Libby, tell me how to do it. You be the teacher. I'm listening. I'm going from what? Yeah. Mm-hmm.
It's gonna go from 0.7 to
0.7 what?
liters, 0.7 liters to
Equals how many what?
7,000 milliliters.
What's it? Milliliters, right? All right, so what are you gonna go? That's milliliters,
You're
uh-huh.
gonna go to
Where do you
the
start?
right.
Where do you start?
You start at 1,
Why would you start at 1?
because that's the base.
So 1 means I wouldn't put a prefix in one of, would I? See? Liters means 1. Okay, so I'm gonna start there. How many steps in what direction? Don't say up or down, it's left or right. So
3 to the right.
1, 2, 3 to the right. I bet if you move the decimal 3 to the right, I bet you get the right answer. What is the answer now? Go ahead. Ready? 1, 2, 3, 700. Now, you may think I'm lying to you because this is so simple, right? And maybe you didn't like, maybe you thought the metric system in the past was something that wasn't simple. It is simple. It's based on this powers of 10, isn't it? All right, let's do another one. This is going to be a hard one. Since that number is erased, let's make it up. How about 380? Let's do a 380. And how about Sally? Sally, you want to show off a little bit? Not really. But Sally, how would we do this one? 380, what's A? 380 what? What's A stand for? Angstrom. Mm-hmm. Equals how many microns? All right, where you at? Ooh. Can I tell you something? That if you'll go home tonight with a blank piece of paper and make 10 to the 12th and make little steps all the way to 10 to the minus 12 and see how many prefixes you know and the abbreviation, that is part of the quiz. You get it? All I can tell you, that is the first part of the quiz. And if you can't do that, you're going to have trouble with these too, aren't you? So my best advice is go home and get a new piece of paper and do that. All right, go ahead. I'm ready. Sally, what do you start with? Where are you going to find angstroms on this thing? Even though angstroms is not a prefix, what power of 10 is it associated with? 10 to the minus 10. All right, so you start at 10 to the minus 10. That's over here, isn't it? Okay, so that's where I'm going to put angstrom. And where are you going? Where's micron? Okay, so you start here and you go 1, 2, 3, 4 to the left. All right, so you go 4 to the left. All right, what do you think? What's the answer then? What do you think? There's no way you walked in here today thinking that you could do 380 angstroms equals how many microns? But you can, can't you? All right, there we go. Oh, that's erased, so don't worry about that. How about, let's see, Dave, you want to do this one for me? Read it to me in English. Dave, read this one to me in English, and then tell me how to do it.
Yeah, that's 2.21 microjoules.
Not micro.
Megajoules.
Not my, that's a big old M. That's a big one. Megajoules.
Equals blank gigajoule.
Okay. How are we going to do that?
Move the decimal point to the right 3 spaces. So that would be
To the right? You're starting at mega. I thought you were going to giga.
mid left.
That's 3 to the left, right? Aren't you going 3 to the left? So, wait a minute. If you're going to use this sheet here, you got to put it in the right direction. If you use, when I build my stair step, the big guys are over here. You get that? The big guys have to be over here. All right, help me, Dave. You kind of dropped off on me. How many steps in what direction? Yes, so what's your answer?
0.00221 gigajoules.
That's right. That's exactly right. Now, let's do, let's go down here to number 11, because I do, this is an honors class, and I'd like to see if you can do this one. So, you think you can do that one?
Yeah, I can do that one.
Really? All right, let's do it.
What does it say?
1 billion micromoles equals how many millimoles? You said, I don't know what a mole is. You know what? It doesn't matter. It doesn't matter.
All right, so we started at micro, and we're going to the left 3 times. So you're taking, basically you're just taking 3 zeros away, so it changes to 1 million millimoles.
You did it in your head. I like that. Now, some of you can't do that. So some of you would have had to do this. And I like what you did. Do you like numbers? So here's a million. How do you write a billion? So I had to start with a billion, and you said that the stair step said move the decimal 3 to the left. And that gives you what number? A million. Wow, you did that in your head. I like that. What do you think? Let's do one more. And unfortunately, the hole punch got right in the way. So let's do this one. Okay, let's do this one. 3.5 kilograms equals how many centimeters? Okay, if you can get this right, you know what you're talking about. So everybody try it. Try to do it within 30 seconds. See if you can get it right in 30 seconds. 3.5 kilograms equals how many centimeters? Now, I tricked you a little bit because if you really know what you're talking about, you should be done in less than 5 seconds. So if you're still working on it, you don't know what you're talking about. You know, it's nice that the stair step tells you how to change metric to metric. And I know you focus on the prefix, but let me translate this into English. What if I said 3.5 pounds equals how many inches? What would you say then? You can't do it. You can't do this one. Oh, I looked at the prefixes, but this says kilograms. You change it to what?
Centimeters.
I can't do that.
Yeah.
Can't do that. Come on. Okay. I threw that in there just to see if you're paying attention. Now, the last thing I want to show you today, the new part of the lesson, I want to go back to this one more time. We've looked at this every day now, and I want you to pay attention. This is important. When I look at this chart, every one of these numbers up here, all of these numbers here that have a positive exponent, what can you tell me about them? If they have a positive exponent, then what are they?
They're before the decimal. So that's how
Well, they may have a decimal, but the decimal's on the right-hand side. But these are big numbers, aren't they? Like 10 to the third is 1,000. 10 to the second is 100, right? But what about all the numbers that have negative exponents? They're not negative numbers, but they are decimals, aren't they? So they're little guys. They're smaller than 1, aren't they? I don't mean negative. Can you remember that? Is that hard to remember that? 10 to the 6, that's big. 10 to the minus 6, you're not big. You're a decimal, right? If you can remember that, I can teach you scientific notation. Now, I will show you how they do it in math class. And I'm going to tell you not to do it that way. I'll show you how you do it in your book. I'm telling you not to do it that way. Now, some of you, because you're only 10th graders, you like rules like this. And here's the way they would teach it in a math class or in a chemistry book sometimes. They would do this. Move the step 1, how to put a number into scientific notation. They would have 3 steps. And guess what's on the next page? How to take a number out of scientific notation. Now, what I'm going to say right now, I want you to forget. I'm going to say the way they teach it, the way I was taught to me, and I'm going to tell you, don't do it that way. Math book, ready? Move the decimal to create a number between 1 and 10. If you move and then multiply times 10 to something, if you move the decimal point to the right, then make this a negative exponent. and I moved it 1, 2, 3. Now, I do not want you to do it that way. I do not want you to do it that way. Because guess what? You had to remember that if I move the decimal to the right, it was a negative exponent. Guess what's going to happen on the next page in the math book? When they say, how do you take a number out of scientific notation? They're going to use the word left and right again, aren't they? What happens if you switch those around? You miss them all. You're not thinking. You're just trying to do, like, bake a cake. You're trying to just follow instructions, aren't you? Let me show you how to do it so you'll never have to remember the rules. And here's what I'm going to do. I am going to use the same rules they did. We have to create a number. By the way, scientific notation, because scientists use sometimes big numbers, and even small numbers are big, aren't they? 0.0000005. That takes up a lot of space, doesn't it? Scientists figured out very quickly, I don't want to do that. I can't even quickly tell what the number is. Why don't we make it a way that if I look at the number and glance at it, I know exactly what you're talking about very quickly. That's why it's called scientific notation. It's a note. It's a quick way to say it. So here's what I'm going to do. Ready? We're going to do all 10 of these at once. All right, ready? Step 1. I like the first step. Create a number, move the decimal until you create a number between 1 and 10, not counting 10. Think about money. If you move the decimal here, 0.5, that's 50 cents. That is not between 1 and 10. So the only place you can move is here, right? So let's try that. Everybody do step number 1. Let's try it. 5. Let's go around the room. Here, you tell me about the first one. I did the 5. What's the second one going to be? Move the decimal to create a number between 1 and 10. What? 5,000 is between 1 and 10?
Oh, no.
Move the decimal to create a number between 1 and 10.
Okay, then 5.05.
Oh, yes. All right, next, go.
Oh, 8.
Yes, next.
1.
Yes, Dave. Hey, is everybody on this page? Dave, move the decimal to create a number between 1 and 10, not counting 10.
1.
Yes. Next.
2.5.
Yes. Next. Yes. Next. What? Yes. Next. Sally, you're next. Yes. Next. 50 is between 1 and 10? Well, okay. There you go. Now, are you okay with step 1? Now, step 2 is when you start moving that decimal, you were playing around with my powers of 10, weren't you? Weren't you? You were stealing some of my powers of 10, so you got to pay me back. So let's put times 10 to the for all these. Because you got to pay me back those decimal places you took away. Okay, I will. Do 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 do. Da, 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 da. Are you okay? Okay? Now, do you remember that page 1 I told you about? This number here better equal that number there. This has to equal that number, doesn't it? Let me watch this. Now, what kind of number are you? Small. A small. Well, then, what kind of an exponent would you have?
Negative.
Positive or negative?
Negative.
Negative. And how many places did I move it?
3.
-3. Look at this guy. What are you? Oh, big. Big? Then what kind of exponent will you have? Ready? I moved it 1, 2, 3. Do I leave it as positive 3 or do I put -3? What kind of number is this right here? Big or small? Big. What about this one? I think I did it right. What's the next one? What kind of number are you? Small. How many places did you move the decimal?
4.
I'm done. What kind of number is this? Small. What about this one?
That's big. No. That's big.
Small. Small.
Oh, well, the next
I think I did it right. Next one. What do you think? Oh, big.
Big.
How many?
3.
Are you going to leave it 3 or -3?
3.
Leave it 3. What about this guy?
Big.
Big. Oh, real big. What are you going to put here?
6.
All right, let's do the next one. What do you think? I'm small. How about the next one? That's small. What about you?
Small.
That's small. How about this one? How big? How many?
2,
How big?
3.
What do you think?
Good.
Is that something you don't have to remember left and right, do you? I know some of you want to do this. Oh, better go home and memorize left and right. You're going to make a mistake. Now watch what happens when I do the other. Why don't we take a number out of scientific notation? Are you ready? I'm not going to do it like the math book. I'm not going to do it like your chemistry book either. Are you ready? You see this number here? What kind of number is this? It's big. You got to move that decimal place point 3 places, don't you? Don't ask me left or right. When you get done, you try it both ways. And when you get done, what kind of number should it be?
Oh, big.
If it's not a big number, you went the wrong way. Isn't that easier?
Yeah.
I better get a big number when I get done. Here's my original number, and I have to move the decimal 3 places. And when I get done, I better have a big number. How many? I move it 3 places, right? So what do you think? Which way are you going to go? Gonna go this way? No. 1, 2, 3. What do you think about that? What kind of number is this? Big. What about this one? Big. I think I did it right. All right. Let's go around the room. Everybody's going to do one. We'll start with Sarah. Ready? Sarah, walk me through that. What do you think about that number?
That's a small number.
He's small, isn't he?
So you go move the decimal points 3 over to the
Uh-huh.
left.
It doesn't matter. You're just going to move it until it gets a small number, right?
Oh,
You don't have to memorize left or right. But you're right. You are going to move it left because that's going to make it small, isn't it?
you have to be 3 over to the left.
You know why? You know why? Because if I start with 1.5, if I move the decimal to the right, it becomes a big number. And you tell me this is what kind of number?
Small, so you go to the left, but do you move the 3 over to the left?
No, not the 3, but that's how many places you move the decimal.
Yeah, do you move it 3 over to the left?
No, not the 3. I move the decimal 3 places,
That's what I said.
but not the 3.
Yeah, I said do you move it 3 places over to the left?
Oh, 3 places. Is that what you said?
Yes.
That's correct. What's your answer?
0.0015.
What do you think about that? All right, next. Lauren.
It's a small number, so
It is small.
you move it 2 times to the left,
And
so it would be 0.0375.
this is way easier than they try to teach it in math and the way they try to teach it in some science books. If you know that chart on powers of 10, then this makes all the sense in the world. All right, next, Carter.
It's a big number.
It is.
So you would move the decimal over 2 places to the right.
And you can try both ways, right? But one of them will give you a big number when you get it. What is it?
It's 375.
Yes. All right, Dave. What kind of number is this, Dave? Oh, okay. He's
That's,
busy.
220,000.
Like that? Okay, take a look. Dave, what kind of number is this? Big or decimal number? He's big. So you had to move that decimal 5 places. When you get done, it better be a big number, right? So you moved it 1 place, and then you moved it 2, 3, 4, 5. Very good. All right, next.
All right. So it's
Okay.
negative 1, so it's going to be a little number.
Decimal, huh?
Yeah, so we got to move it over 1 to, so it's going to be 0.335.
Good. Next.
It's a small number,
Yes.
and you're gonna move it over 4 places to
Ooh.
the left. So it's gonna be 0.00014.
So it was here, and you moved it 1, 2, 3, 4. That's good. Very good. Next.
1 times 10 to the 4th, so you move the decimal over 4 times.
And also, you're supposed to know what 10 to the 4th is anyway, don't
Yeah,
you?
it's just 1,000.
What is it?
1,000.
I thought 10 to the 3rd is 1,000.
Yeah, sorry.
Okay, so 10,000, right? Next one, Sally.
1 flat,
Yes, next.
4,
Eureka. What?
4,
That's right. And matter of fact, 4 times 10 to the 0 is the same as 4 times 10 to 1. So we can write 4, or you could write 4 times 10 to the 0. Like that's all right. Now, I have one more thing to teach you, and then we'll be done. Look at my time here. Time. Oh, good. Wait. Yeah, we have time. Yeah, good. Now, what I'm going to show you here is, it's not hard. It's not hard, but it's something that is a little beyond this, okay? So a little bit harder than this. Sometimes in science, you'll be doing a calculation with scientific numbers. So you have to be careful of that because I'll show you how it works. What if I had something like this? Well, let's do that. Let's do 8,452 times 10 to the minus 2. Well, what if I make you, and I will, what if I make you put all of your answers in scientific notation, and this is what you have? Well, then how do you put it in? How do I know this is not in scientific notation? How do I know?
It's the big number, the small, with the negative 2.
Well, the first part of the number is not between what? It's not between 1 and 10. That's why it's not in scientific notation. So let me show you 2 ways. I'm going to show you 2 ways of doing it. Every year I do this. Some people like the first method, and some people like the second. Method number 1. This is the one, should be the easier of the 2. Now what I'm going to do is, hey, you're not in scientific notation because, see this part? You're not between 1 and 10, are you? So what I'm going to do is I'm going to act imaginary. I'm going to forget that see this 10 to the minus 2? I'm going to act like I don't see it. Put this part in scientific notation. Okay. 8.452. It's a big number, isn't it? Times what? What is this? 10 to the what? 3 or negative 3? That's a big number, isn't it? That'd be 3, yeah? 10 to the third. So now I put this number in between 1 and 10. I made it in scientific notation, didn't I? Now I got to come back because then I had this thing I forgot about, didn't I? So now what do? What does your math teacher tell you? When you multiply numbers with exponents, what do you do with the exponents? For example, what's x to the third times x to the fourth?
You add exponents.
It's not x to the 12th, it's x to the what? 7. When you add numbers with exponents, multiply numbers with exponents, you add the exponents, don't we? So my final answer will be 8.452 times 10 to the what? To the first, right? Is everybody okay? Yes.
Where did you get 10 to the 3?
Okay, what I did is I covered this up, and I said, let me put this number in scientific notation. And what is that?
8.452.
Times 10 to the what? He's big. Times 10 to the what? I had to move the decimal 1, 2, 3 places, didn't I? 10 to the third, right? Okay, now but I can't forget this guy. He's still part of the number, isn't he? So I'll put him back. And now, so method number 1 is pretty concrete. You can kind of make sure you get it right that way. Yes?
What was the method you just described trying to achieve?
Oh, okay. Sometimes you'll do a calculation, and it'll come out like this. And yet, you want to express this answer in scientific notation. This is not scientific notation because, look, Dave, the first part of the number is not between 1 and 10. So I have to convert it to it is. Now, I'd like to show you another way. Now, some of you are not going to like this method because it's like a little bit higher level, and some of you like the underhand serve. The underhand serve says the ball is going to go over the net. I like the underhand serve. I'm going to show you the overhand serve way of thinking. Now, you can decide which way you like. Here's my thinking. Ready? Oh, you're not between 1 and 10. As a matter of fact, okay, is it frozen? don't know why it does that. Okay, you're not between 1 and 10. I gotta make you between 1 and 10. So 1, 2, 3. Hey, you just took 8,452 and made it 8.4. You just made me you made me 3 powers of 10 smaller than I used to be. Pay me back. Pay me back. If you made me this part of the number 3 powers of 10 smaller, you better make this part 3 powers of 10 bigger. If you made this part of me 3 powers of 10 smaller, you better make this 3 powers of 10 bigger. What's 3 powers of 10 bigger than 10 to the minus 2?
It goes up 3 to 6.
Oh, 10 to the first. Now, my own opinion is, we're going to do one more of these. My own opinion is, if you don't like that second method, do the first one. Let me give you a hard one? Yeah, let me give you a hard one.
Give it to me.
Ooh, okay. Okay, I ran out of space. 0.0064 times 10 to the minus 4th. Okay. All right, try method 1. Thank you. Try method 1 and see what you get. Then try method 2 and see if you get the same answer.
Is it 10 to the negative 6?
Yeah, 10 to the minus 4. So it's 0.0064 times 10 to the minus 4th. All right, how we doing? So let's say I only taught it once, so let's do it again. If I saw this, I would cover this up, and I'd say, let's just put this part of the number in scientific notation. What would you get? And this is a small number, isn't it? Are you okay with that? Are you okay with that? Is this that?
Yes.
Now I'm going to uncover this and put it what? 10 to the what?
-7.
So my final answer would be, yes? Now, let's try method number 2. Yes, Carter?
Question, is it negative 3 because you're moving to the right?
I don't do that.
I mean,
I don't do that. You know why it's negative 3?
why?
Because guess why? I'm small.
Oh, because it was small.
When I take this number here and turn it into scientific notation, it better have a negative exponent because you're a decimal number, aren't you? If you'll remember that, you don't have to remember right or left. If you do, I know the math teacher's going to teach right or left, but if you switch those around, you're going to miss them all. All I do is, when I first see that number, 0.0064, I know it's times 10 to the minus something, don't I? Let's do it the other method. Ready? Hey, you're not between 1 and 10. What? I'm over the decimal. Hey, you just made me a whole lot bigger. You made my number, it used to be 0.006, now it's 6, isn't it? You just made me 1, 2. You made me 3 powers of 10 bigger. We better make this part 3 powers of 10 smaller. But what's smaller than 10 to the minus 4th? 10 to the minus 5th, 10 to the minus 6th, 10 to the minus 7th. You know what? I don't care which method you use. Do you like the first method or the second?
First.
Then use the first. It's going to go over the net. The underhand, it's going to go over the net, isn't it? Everybody okay? See, as long as you have one way you're going to get it right, just use it. If later you want to think about the other way, that's okay. I want to show you one more thing. I have about 2 minutes. I put one of these every year on the test, not to play with. I'm not playing with you, but I'm trying to force you to stretch yourself a little bit. So let me watch this. Now, you cannot use a calculator on the first quiz or the first test. So let me give you a problem. How are you going to do that without a calculator? You know? All right, let's go.
Well, first for multiplying the top, all you have to do is just take away some of the zeros. So you can just do it.
What are you going to do?
And then every
Oh, well, let's do a scientific notation. How about that? What's the first number, real quickly? 4 times 10 to what?
Do a negative,
3?
yeah,
Positive or negative 3?
positive.
It has to be. It's a big number. And then times what?
3x 10 to the fourth,
Okay. Okay. And then what's the bottom number?
6x to the negative 3.
Ooh, almost.
That's negative
4, negative 4, right? All right. Ready? Let's do the top part. What is 4 times 3?
4.
Okay, 12. I'm running out of space. 4 times 3 is 12. Now, what's this times this? Times 10 to the 7th. And then you divide by what? 6 times 10 to the negative 4. All right, what's 12 divided by 6? What's 12 divided by 6? Now, when you multiply numbers with exponents, you add them. But what if you divide numbers with exponents? You subtract the top minus bottom. Everybody get that? So my final answer is 10 to the 7 minus a minus 4. 7 minus a minus 4 is 7 plus 4, isn't it? What do you think about that? So I put one of those on every test just to see if you can do the scientific notation and you can divide or multiply things like that. What do you think about that? Now, I'm not giving the quiz at the beginning of the period, am I? So we're going to review. We're going to review scientific notation tomorrow, and I'll review anything you want. And as long as you know your prefixes and we review, I think you're going to do very well in the quiz. All right, thank you.